In this video, we're going to focus on what our radical equations look like. So in the last video, we talked about them having the same kind of general form as a quadratic, except rather than squaring this x minus h, we're taking the square root. So like we saw last time, the domain for a square root is restricted, right? So we have it, it's going to start in one place and then go in one of two directions. So this Desmos page is really nice because it can show us what changing some of these values looks like. So let's start with A. If I click here, we can see that while A is getting large, it's raising how fast it's growing. And I can zoom out a little bit to give a better view of that. And then as A goes below 1, or even just as A is decreasing, we can see it flattens out. And then if it goes negative, it flips onto the other side of the axis. And then if A is 0, that makes sense. It's zeroing out this entire piece, and we just have a line at K. So let's move this back to 1. Just like we would expect for a quadratic, this H and K are just going to shift along the horizon, or along the horizontal. And vertically. So we can actually see as these two are moving, it's just going to move where we're starting from. So we can still think about this piece, this starting point, as the vertex. Let's calm this down. So something that I hinted at in the last video, let's say I have this starting point at 1.50. That would be my vertex. You may be inclined to write the function as and you wouldn't be wrong. This is one of the functions. This is what it looks like. But when we're looking at standard form for all of our types of equations, we normally avoid decimals. We'll normally write these so that they're all integers. And how we go about doing this is we can think about this as an x minus 1.5 equals 0. If I wanted to get rid of this decimal, I would need to multiply by 2. So really, I would want to write this equation as 2x minus 1. That would be standard form for this. Now, this is a different function. The function square root of x minus 1.5, the square root of 2x minus 1, they are slightly different, but they have the same vertex. So for our purposes, this is the one that we would want. If we were trying to figure out what the exact equation was, it would matter what this A is. And to figure out what the exact equation was, we would need some other point on the function in order to exactly figure out how to write this. We're not going to worry about that. We're just trying to focus on, can we figure out where that vertex is and in which direction it's going. So we have that for square root. Everything is going to work the same for cube root. So it'll look kind of like that square root does, but when we have a negative value, it comes out negative. So it does this little reflection. So we still have this vertex, right? We still have the vertex that's going to decide where we do both of these little loops. And so it comes out to be the exact same thing. It's written as 1/3 here because they don't want me to put in the cube root. But this looks exactly the same. And just like before, if I had something like x minus 1.5, then I would switch it to write it with integers. Now, on the exam, I'm not going to deal with that. It gets a little tricky. That's not the point. The goal is to recognize what these functions look like and where that vertex is. So if we want to summarize, and I'm going to write that explicitly. So if we have a square root, or really any even root, which is why I wrote it, then it'll either look like this, or like this. And we saw in the last video how to figure out which direction it's going by setting what's underneath the radical greater than or equal to 0. But then if we have this negative value, what it'll do is flip it. So this will get flipped along the x-axis, and it'll actually look like this. And then if it ended up pointing in the left direction, it would look like this. So for cube root, or really any odd root, just like before, we'd find that vertex, and if it's positive, it combines both of these, the domain, because the domain is everything. And then if we had a negative out front, it would flip it. We still have this. Instead of growing, it was actually going down and would continue to go down. So the way to remember which way these cube roots are going is this general direction that things are heading. For the radicals, it's a little bit tougher because we would actually first need to figure out which direction is our domain heading in, and then we would flip it for the negative version. But for cube roots, it's easy. If we have this a is positive, this value outside is positive, then it's generally growing as we get larger. And if this a is negative, it's generally decreasing.